Hi, and welcome to this quick tool review. This time around we're going to take a look at some milling cutters from BangGood. They are carbide cutters, solid carbide cutters that are coated. 45-degree helix angle on one, 55 on the other two. This cutter over here is good for up to Rockwell hardness 50. These two are supposedly up to Rockwell hardness 55. They're coated with aluminum titanium nitride. This one doesn't say, but it looks like titanium nitride. They're all from the same manufacturer. I'm not quite sure how you pronounce the name, but at the outset, the quality looks excellent. Here's a close-up. As you can see from the grinding marks, the grinding quality is very good. The edges are razor sharp and very comparable to other name brand milling cutters I've looked at in the past. Sorry about the motion and the focus. It's very hard when you're zoomed this far in to keep things steady. And here's the end of the cutter coming up. That's one side, and here's straight on. You can see, very nice. So these cutters are all 10mm cutters, and a half an inch is 12 and change millimeters, which puts these guys very close to a half-inch cutter. Yet look at the price: $11.89, $14.69, $14.57. At that price, if they're a quarter as good as the competition, they're a little more time in changing out parts, but they're still worth it. Most half-inch cutters that I've looked at, from a big manufacturer, go anywhere from the mid to high 40s all the way up to $100 each. So these could be an excellent find, and that's what I'm looking for. I'm looking for a deal for the home hobbyist that will work out well. We're going to put these through their paces a little bit. I'm going to run them on a piece of hot or cold rolled steel. I'm not sure. It's sort of an unknown piece of steel. And I'm also going to run a couple passes on this hardened 4140 I had in another project of mine. And it should be about Rockwell hardness 50. So it should be right at the limit of this guy and within the limits of these two over here. The finish looks really nice on the cutters. The grinding looks excellent. So from reading a little bit, my understanding is that there are a few tungsten carbide powder manufacturers in the world, some really good ones in Germany, and let's face the facts. Anyone can buy from those sources and then make your own cutters, and then the CNC grinders are available, so there's no reason these can't be very good cutters. Now, I'm not saying they are. I haven't tested them yet, and longevity really is the ultimate test, but it's really got me sort of optimistic about finding decent quality at a low price that the home hobbyist can afford. So let's pop over to the mill and run some passes with this guy over here. So first pass, we're going to try and clean up this edge. And I'd like to point out that what we're going to do is actually what's hardest on a cutter, because the cutters are strongest up the axis. So if you're plunging with them, they're actually the strongest, and they're most likely to weak. You get the biggest torque arm when you're doing a radial push, which like we're going to do here, rather than an axial push. So what I'm going to do is try and clean up this edge in two passes. It looks like the flutes aren't quite long enough to clean this up in one pass. You can see this is a scraggly, nasty mess. So let's just run a few passes, see how it does. We'll take some light cuts first just to get our feel and then be more aggressive. Let's start at 1200 RPM. Alright, so let's take a light pass. About 25 thousandths. Oh, I'm sorry, this is conventional milling. And it looks like this piece isn't even a little bit square because I feel like we're biting more and more. The color of the strips is straw, which according to one of the books I'm reading says if you keep your cutters where the chips are straw colored all the time, then you'll be just right and you'll get maximum life out of the cutters. I'm just going to go back and clean up all the debris real quick. Surface finish is very nice. Alright, so we're going to come back and I'm going to do climb milling on the way back, see how that works. Got to be careful not to break the cutter. So we're going to lower this. So the health, the cutter looks fine, feels sharp. It's interesting that there is a slight depth change, like it was deflecting this a little bit more, and it might be because I'm reaching in. They may not have made the upper diameter the same as the flute diameter. I'm actually not sure. It looks really close, but I'm not sure. So let me clean up again. So I tried another pass here, just a really light one to see how things would clean up. And I don't have that transition anymore. It's a nice smooth finish. No difference between the various depths of cut. I guess the first time through, it was a big enough cut that was deflecting the material just a little, the cutter just a little bit, because I could just with my fingernail just barely feel that edge that you could see. So went back with a lighter pass and cleaned up nicely. All right. Here's 2,000 RPM. And it's coming to a big bite here at the very tip, which is really going to stress it. Also, the material is weldment, so unknown material. And since it's sparking differently, it's obviously different material. Much harder material. I'm going to slow this down a little bit. That's much harder material. I can. Boy, when you hit that material, you can really feel it. Got to take it easy, but it is cutting it. It is a lot harder material. The amount of force it's pushing back is immense by comparison. It was just gliding through it, and now I'm actually having to really push. Right now we're conventional milling. Cleanup pass. So when I'm doing conventional milling, the little chips that it's cutting off don't all get ejected from the flutes, and some of them whip around and get pressed back into the metal, and they come in the backside and get pressed on, which is kind of weird. All right, so now we're going to use it just to cut a little bit of material off the face all the way across. There's weldments on this side, all along the edge, and this side, and they are significantly harder, and you'll hear the whole mill bog down when it gets to them. So let's start with a light cut, because I'm not sure how. Also, this is sticking out much higher. So let's start 15 thousandths in a reasonable feed rate. Now I'm slowing the feed rate down. I'm down at the much harder material, and you can hear the sound change on the cutter. Where a weldment was removed, so I expect it to struggle more when it gets to this side here. Alright, very nice. Excellent surface finish. I changed the feed to much faster on the way back, and we have a really nice finish on this guy. All in all, I think these guys are a good deal. Let's take the cutter out, take a close-up look, and see what it's like after biting into the weldment, and see if it incurred any damage on this really light usage. Of course, I'm not using any lubricant or coolant. So after a bunch more passes off camera, I did square up the entire block and surface both faces, and the end mill performed really well. You can look at the edges here, and you can see that, I'm sorry about the focus, it's really tight, that the edges turned out pretty good. There's a little bit of wear at the edges on the very end, the corners, but this is a square edge end mill, and I suspect that they wear pretty quickly, even in the best of end mills, because it's a very vulnerable part. I think the overall performance was good, and remember that when I'm hitting that weldment from the normal material, it's essentially an interrupted cut from softer to much harder material. So they did really well. So my final evaluation, these bits are a good value. There was a little wear on the end of this cutter, but I was cutting really rusty welded material, and you know there's all kinds of oxides, and those oxides are extremely hard and damaging to cutters. As a matter of fact, I think the normal recommendation is not to use your good cutters, especially your finished cutters, on heavily oxidized or welded material because it can damage them. So I think generally these performed extremely well. A great price, 12 bucks for nearly a 1/2-inch cutter, 10mm. Oh, and don't forget that you will have to buy yourself a set of 10mm, metric collets, R8 collets. So another option is to get yourself an ER32 to R8 collet and buy ER32 chucks in the various metric sizes. It can be handy. They can get really small, so you can use them to hold drill bits and other things if you can't afford that extra space that the chuck provides. So that's another option for you. Also wanted to point out that I didn't use the 4140 because I actually have another use for it, and I thought going through the weldments would be a good enough test of going through really nasty material. So in general, thumbs up, good performance, great value. One more thing, I did put links down below for you to find these specific cutters. If you're looking, BangGood's site is a little bit challenging to find milling cutters on. They don't really have a section for machine tools, even though they carry machine tools. So look around, you might be surprised. I've been pleasantly surprised by almost everything I've gotten so far. A couple items were not up to snuff, but for the most part, excellent quality, and especially for the price. Thanks for watching. Hope to see you next time.